Let's wait for the confirmation na lang. Okay, so we are now recording, and this session is about chapter 4, the last chapter prior to your midterm examination. Okay, so for our session today, we'll just have basic discussions. Puro terms lang tayo. And then the calculation will be done in an asynchronous manner. Okay, so next week na to, pero asynchronous. So you'll have more time to work with the requirements. Na. Okay, so in our session today, we'll talk about titration, the types of titration, the endpoint and the equivalence point, and the titration process. Okay, so let's begin. Okay, so titration. Who among you were able to do titration during high school? Sino sa inyo nakapag-titration yung senior high school? Wala. Okay lang naman po. Wala. Okay. Kasi yung ibang, nakalimutan na. Okay. Pero yung iba kasing student ko dati, they were able to do titration during their senior high school, especially for STEM students, no? Um, Usually sa triple I nila yung increase immersion and increase investigation immersion, something like that. And yun, yung iba naman sa Gen Chem na pinagpala sila. Okay? But yan, since I think not all of you are aware with what titration is, um, titration is a volumetric analysis. Okay? 'Di ba last time we had gravimetric analysis in the laboratory? Okay. This time we are now in the next type of analysis in analytical chem. Remember, apat yan. Tapos na tayo sa gravimetry. Nasa volumetric na tayo. Okay? So, um, titration is a volumetric analysis, meaning you have to deal with chemicals, no, that are in the liquid form. Okay? And then you will mix them, and according to how much you used, that can tell you the number of substances present in your sample. Okay? So depende kung gaano karami yung liquid na nagamit, ganun din karami yung chemicals na nandoon sa iyong analyte. Okay? So yan. And typically, this is how your titration setup looks like. You have a burette here. I am actually planning to purchase one, but when I look up sa Shopee yung price, ang mahal pala. Mga 1,000. Sabi ko, wag na lang, mag-imagine na lang tayo. Okay. Pero sa if ever mag face to face tayo, marami ng ganito na. Okay, marami ng burette sa FEU. Okay. So this is how your typical titration setup looks like. You have your burette here, which is clamped, okay? And this contains the titrant. Okay, later we'll define what titrant is. Okay, so mangyayari, you will determine how much of the titrant will be transferred to your analyte solution. Okay, so kunwari, it consumed 10.5 ml of the titrant. So that means um, you can determine the moles of the titrant, no? Yan. Okay? And then magre-react siya with the analyte. Okay? So yan yung typical itsura niyan. And then you have your stir bar. O kaya kung wala naman stir bar, you have to manually shake it. Okay? So yan. So there are many types of titration. We'll discuss them later. Okay, but the focus of chapters 4 and 5 in both lecture and lab will be on neutralization titrations. Okay, so basically when you say neutralization titration, you have your neutralization reactions happening. What's neutralization reaction ba? That's the reaction between acids and bases. Okay. So either your titrant is an acid, your analyte is a base, or vice versa. Your titrant is a base, your analyte is an acid. Okay? And then depending on how much of the titrant was used, you can infer how much analyte are there in your sample. Okay? So, yun yung ginagamit para malaman kung gaano karaming nandyan sa sample mo. Okay? So, yun. So, in a titration, increments of reagent solution are added to the analyte until the reaction is complete. Okay? So, kumbaga, patak-patak lang yan. Okay? Parang inuman lang yan. O, patak-patak. So, you just open it very slowly and then you will see your liquids falling dropwise. Okay? And as they fall into the analyte solution, they do some chemical reaction. Okay? And then you will know when the reaction is complete kapag kunwari, let's say may color change. Okay? May nilalagay kami dyan para maging colored siya. Okay? So that is the phenolphthalein indicator. We'll talk about that later. Okay? So yun, you will add your titrant slowly, dropwise, until you see changes in your Erlenmeyer flask. Okay? So pag nagbago siya ng kulay, that denotes that the reaction is done. Okay? So yun. And when transferring liquids, we don't use pipette, rather we use what's called a burette. Okay? Familiar naman kayo dyan with the burette in the lab, right? So you know how to operate burettes, diba? Okay? So yan, nakaklamp yan. Okay. So now, let's go into the terms that we use in titration. Okay? So, kasi may mga terms yan. So, para maging familiar tayo, let's talk about them. So, first is the analyte. Analyte, ito yung hinahanap. Okay? So, I know we are aware what analyte is, di ba? So, analyte, yan yung ina-analyze. Okay? That is the one being sought. Okay? Siya yung walang concentration na known. Okay? So, ibig sabihin nun, hindi mo alam yung dami niya, hindi mo alam concentration niya. Okay? So, yun yung analyte. But the titrant is the opposite. No? The titrant or the standard is the substance with accurately known concentration. Okay? So, si analyte, di mo alam, pero si titrant, alam mo. Okay? So, ganun. And then, para malaman mo yung unknown, for you to know the analyte, you react it with the titrant. Okay? So, parang ganun yung idea. Para siyang, when measuring length. Okay? Si analyte, yun yung object na walang length. Okay? Okay, di mo alam yung length. And then yung titrant or the standard, that is your ruler. Okay? So, depending on how you contrast it with the ruler, pwede mo malaman yung length of an object, right? So, parang ganun din yung analyte and titrant. Okay? So, yun. You react your titrant with your analyte so that you can determine the concentration of the analyte. Okay, so what else are the terms used? We have indicators. Okay, so sometimes reactions are not really that obvious. Okay, kasi tandaan nyo yung ating solutions, transparent yan, right? For example, yung tubig sa bahay, transparent siya. Okay, so pwede natin gawin is we can add some indicators. Okay, and those indicators will change color. Okay, so yan. For example, tignan nyo. Dito, in the Erlenmeyer flask, let's zoom in. So in the Erlenmeyer flask, everything is transparent, no? Even in the titrant. So how will you know that the reaction is complete? Madali lang. You simply add some indicator. So patak-patak ka lang dyan until when you have enough titrant to react with your analyte, siya na mismo yung magpapalit kulay. Okay? And as it changes color, that means that your reaction is indeed complete. Okay? And then we have the terms equivalence and the endpoint. Okay? Equivalence point and the endpoint. Okay? So what are they? So yung ating indicator kasi, when it changes color, it actually denotes the end point. Okay? Meaning, tapos na yung reaction mo. Yan. Okay? So, yun yung pinaka ginagawa niya na the reaction is complete na. Tapos na. Okay? But, yung more accurate na stoichiometric equivalence, we call that the equivalence point. Okay? Pero yung nakukuha natin in the laboratory, that's endpoint. Okay? So, yun lang yung distinction nila. Both of them indicates that the reaction is complete. However, yung equivalence point, yun yung theoretical. Okay? But when you have your endpoint, yun yung experimental. Okay? So, yung equivalence point, since it is theoretical, it can be calculated using stoichiometry. But for the endpoint, that is the one being determined in an experiment. Okay? So, yan. Okay? So, yun yung mga terms na bago. So, you have to be kind of familiar with them. So, you have your analyte. Okay? You have your titrant. Okay? Yung isa unknown, yung isa known. Okay? Yung titrant or standard, that is the known. And then your indicators, they change color when there is enough titrant to react with your analyte. And then equivalence point and endpoint, they both tell you that the reaction is complete, but for the endpoint, that is the one being observed, and then for the equivalence point, that is the one that is calculated. Okay? Naghahanap ako ng picture ng titration sa cellphone ko, kaso wala pala. Akala ko may pictures ako dito. Okay. Anyway, so yun yung terms ha. Okay, so tandaan nyo yan. So, to show you how titration works, okay, syempre wala tayong laboratory and ayun nga, I was planning to purchase the materials but upon checking, they are expensive. So, let's watch a video muna, okay? So, let's imagine how this works, okay? So, I will reshare the screen again kasi hindi ko nakalimutan ko yung audio. Yan. Okay? So, let's watch this video muna, okay? And let's see how titration works, okay? Imagine nyo nasa Caroline na tayo.
Hi, I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today, we will be discussing the proper titration technique using the complete single burette assembly kit available from Carolina Biological Supply Company. This is the first in a two-part video series on titration. The purpose of a titration is to quantitatively determine the concentration of an unknown solution, commonly called the titrand or analyte, by adding a volume of a chemical with a known concentration called the titrant. To mark the endpoint of a titration, an indicator is added to the analyte. Let's review some of the equipment that's needed for a titration. Carolina's complete burette assembly contains the basic equipment to get you started, including a burette, ring stand, and a burette clamp. A burette is a long, narrow, graduated tube used to add titrant. It has a stopcock to regulate the flow of liquid. Notice that the markings on the burette go from lowest at the top to highest at the bottom. The ring stand and burette clamp are used to mount and secure your burette. Other materials you will also need include a small funnel to help you fill the burette, a 125 milliliter Erlenmeyer flask, which works best for titrations. The shape of the flask allows for more vigorous swirling than a beaker or other glassware and minimizes spill hazards. A volumetric pipette and pipette bulb to transfer a known volume of analyte to the flask. A wash bottle filled with deionized water, a beaker or flask of titrant and of analyte, indicator selected for your reaction, a reading card to help read the meniscus, and a sheet of white paper to help visualize the endpoint. To prepare your burette for the titration, it is good laboratory practice to rinse your burette thoroughly with deionized water
Ba't kaya biglang humihinta?
then with a small amount of titrant. After each rinse, open the stopcock to allow the liquid to drain out the bottom. If there is a lot of liquid clinging to the walls of the burette, then thoroughly clean your burette and repeat the rinse process. The accuracy of this technique is dependent on the titrant flowing into the flask and not sticking to the walls of the burette. Mount the burette in the clamp, making sure it is positioned vertically and there is enough room to position your flask underneath the tip. Check to see that the stopcock is in the closed position. Insert the funnel into the top of the burette and fill with titrant almost to the top. Filling exactly to the 0 mark is not necessary, but you do need sufficient titrant to complete the reaction. Check the column for air bubbles and gently tap to free them from the side walls. Remove the funnel. Place the Erlenmeyer flask under the tip and open the stopcock to allow a few milliliters of titrant to flow through, releasing any trapped air. Rinse the tip of the burette with water. Empty the liquid into a waste container and thoroughly rinse the flask. It is not necessary to dry the flask. Record your starting volume. It is important to accurately read the volume on the burette. First, note that the liquid forms a concave meniscus because the water pulls itself up the side walls of the glass. You should read the volume from the bottom of the meniscus at eye level. Secondly, it is important to read your volume to the correct number of significant figures. This burette indicates volume to the nearest 0.1 milliliters. With any graduated glassware, record the volume to one additional decimal place beyond the smallest graduation. In this case, record the volume to the nearest hundredth of a milliliter, estimating the final place. Use the volumetric pipette to transfer the analyte to the flask. Add a few drops of indicator to the flask and swirl. Place the flask under the tip of the burette. Record this volume. Placing a piece of white paper under the Erlenmeyer flask may make it easier to detect the color change. Operating the burette requires 2 hands. One hand turns the stopcock, while the other hand swirls the flask. Practice turning the stopcock a few times to familiarize yourself with how quickly the flow starts and stops. It is common laboratory practice that the first titration is an estimate. Open up the stopcock and allow the titrant to enter the flask quickly. Continuously swirl the flask. As the volume of titrant in the flask increases, the color of the indicator appears, then disappears as you swirl. When the analyte becomes a colored solution, close the stopcock. Record the final volume of the burette. Subtract the initial volume from this final volume to get the estimated volume of titrant needed for this titration. Knowing the volume that is a little past the endpoint, subtract 5 milliliters from that number to get the amount of titrant that can be safely added before a slower addition is required. As the estimate titration shows, a dark-colored solution indicates an excess of titrant has been added. The desired endpoint is a pale, faintly colored analyte. To reduce the risk of passing the endpoint, slow down the addition of titrant when flashes of color begin to appear in the analyte. Adjust the stopcock to slow the flow of titrant to a dropwise rate. Continue to swirl the flask with one hand and keep the other hand ready to close the stopcock. When you notice the indicator taking longer to fade, close the stopcock. Rinse the tip of the burette with deionized water and swirl the flask. Record the final volume on the burette. If the analyte remains faintly colored, then you have reached the endpoint. If the analyte is still colorless, then repeat these steps. Add a drop, rinse, swirl, and record until a faint color persists. Typically, titrations are performed in triplicate. Use the average volume of the titrant required to reach the endpoint for any calculations. You now know how to properly perform a titration. Be sure to check out the second.
Hindi ba ang haba? Anyway, so pinakita niya yung mismong process of titration. Okay? So as you can see in the video, he was able to demonstrate how we clean the burette, okay, the proper operation of burette. Okay, so you have to secure it tightly, and then transfer liquid, and of course yung cleaning pinakita niya rin. Okay? And in the yung most important part of the video lang is that yung pag-add ng titrant. Okay? So as you can see, the addition of titrant is stepwise, no? Or dropwise. Okay? Dahan-dahan lang until makumpleto siya. Okay? In normal, what do you call this? Neutralization reactions, we usually end up with pink color. Okay? So, hindi yan dahil politics ng pink talaga yung color niya. Okay? So, that is phenolphthalein. Okay? Paano yun na de-ionize yung water? Okay. Meron kaming water deionizer in the laboratory. Okay. So, kumbaga, para siyang filter. Ah, okay. Para siyang filter na merong adsorbent ng ions. Okay. So, yan. So, parang ganito siya. Parang ganito, So, may filter. And then, itong compartment na to, this have, ion exchange. Okay. May ion exchange system siya dyan para hindi siya maging ionized. Okay. Yun. So, kapag deionized water kasi, wala siyang other ions. Kunwari, wala siyang calcium, wala siyang magnesium. As in, H2O lang talaga nasa liquid mo. Hindi pwede inumin yun kasi it will cause osmosis to happen sa body mo. Okay? Kasi walang ions eh. Delikado yun. Okay. So, ganito yung itsura ng water deionizer in the laboratory. No? When I was college student, ito yung sa amin eh. When I was college student, every morning, like 6 a.m., nakapila na kami for the water deionizer. Like we have, meron kaming maliliit na galon. Tapos nakapila kami. Kala mo may water shortage sa amin. Pero ayan, every student kasi is required to have one. Okay? Siyempre, chemist, kaya kailangan individual yung experiment. Yan. Okay? So, yan. I'll show you another video. Okay? But this time, mas madali siya, mas mabilis siya. Kasi siya ay galing sa TikTok. Alam ko naman may nakikita kayo sa TikTok na titration, right? So, let me show you yung titration sa TikTok. Okay? Tignan natin. Okay, so biglang ganun. Ayan. Okay, so bali ganun lang na. Kaso nakaka-bother yung audio. And so you just slowly open it and then as the liquid gets transferred, okay, so this is a phenolphthalein indicator, kaya siya nagkukulay pink, no? The only thing that is wrong here is that hindi niya siya ni-shake, okay? Tsaka, ang dami niyang na-add agad, na. Sabi niya kasi last 30 seconds. This one naman, let's check this one. May ganun. Ayan. Kung mapapansin niyo, yung mga TikTok, they are commonly showing the frustrations kasi that usually happens, no? Sa akin din, na-stress din ako sa titration. Like, parang you did everything correctly naman, pero hindi talaga. Hindi mo talaga siya makuha in first try. And that's fine. Okay, that's why we have triplicates. Okay? So, kung dito kanina, it is pink. Ayan. Phenolphthalein kapag pink eh. So, ito naman, tignan niya, iba kulay niya. Hindi, phenolphthalein pa rin pala. Pero may ibang kulay eh. Okay. Masyadong dark nga lang yung sa kanya. So, weird. There are titrations na hindi na necessary yung color. Okay. May titrations na hindi na necessary maglagay ng indicator. Especially if your titrant is colored, no? So for example, this one, the titrant here is potassium permanganate. We just know it kasi ganun talaga pag chemist. Tignan mo lang yung kulay. Alam ko na yan. Okay. So ito, hindi mo na kailangan ng indicator dyan because the titrant itself is colored na. Okay. Siya na yung automatically magkukulay pink.
Magnificent pair of bananas.
Ito siya na naman.
Oh, great heavens!
Diba? Mali din yan.
It's about drive, it's about power. We stay hungry, we devour. Put in the work, put in the hours, and take what's out.
Ito, mali din sila kasi super daming titrant na nalagay nila. Okay? Baka mamaya mag-TikTok na tayo buong araw. Okay na yan. Ganun kasi ako. Pag nabuksan ko yung TikTok, wala na. Nakatulala na lang ako buong araw. Anyway. So basically, that's the process na. Okay? So you just add your titrant very slowly to your analyte that is in the Erlenmeyer flask, and then you have to swirl it. There are titrations that require indicators, while there are others that do not require indicators, especially if your titrant is colored. Okay? So yan. So, if you want to watch the video, the link is there. Okay?
It's an excess of titration.
Okay, so, biglang ganyan. In titration process, especially for neutralization reaction, pag neutralization, di ba, nagbabago yung amount of the ions, no? Nagbabago yung pH kasi, kunwari, you begin with an acid and then upon adding your base, nagiging neutral siya. Okay? So, ibig sabihin, you can graphically show the process in titration. Okay? So, that graph is this, no? Ganito yung typical graph sa titration. You have your pH at the vertical axis. Okay, remember, pH is negative log of H, no? So, minsan, your initial pH is very low, meaning it is acidic, okay? And then upon adding your titrant, you will see that the pH will slowly increase. Kasi nga, base is mataas yung pH. So, kapag mataas pH, hinalo mo sa mababa pH, mag-average out sila na. Okay. So, yan. So, upon adding your titrant, the pH will slowly increase because base siya eh. Okay. Okay, and that also tells us that the reaction is ongoing. Okay? So, yan. So, if you attach a pH meter to your titration setup, this is how your data will look like. Okay? So, slowly, the pH will increase and then suddenly, there will be a sudden change in the slope. Okay? If you see a sudden change in the slope, that usually tells an equivalence point. Okay? As you can see, at a very small range of volume, yung pH change super laki, no? So this thing here is called the equivalence region or inflection region, okay? Kapag sinabi kasing inflection, okay, in geometry, biglang ganun, biglang nag-geometry. So in geometry, sa mga curves natin, inflection is characterized by a very steep slope, okay? Kumbaga, dahan-dahan yung slope, then suddenly biglang lumaki yung slope niya. Okay, that's an inflection point. And whenever you see an inflection point, that indicates the equivalence point, okay? Then after nyan, mag-back to normal na uli siya, okay? So, ganyan yung nangyayari. And yun yung ganap sa mga colors na nakita nyo kanina. Diba, as you can see, suddenly, biglang nag-dark yung solution. Okay? So, inflection point yun. Wherein, kunwari acidic siya, and then just by adding one drop, it suddenly, the pH suddenly shoot up, no? So, kunwari, pH 4, tapos biglang naging pH 8. So, ganun kalaki yung change agad. So, that's why you have to be very careful when you are at this region. Okay. Itong region na to, this can be calculated naman. Okay. We will demonstrate that next. meeting sa asynchronous video. Okay? Okay? So, hindi lang ganyan yung titration, no? Pwede na naman pabaliktad siya, wherein you begin with high pH and then it will suddenly slow down. So, dahan-dahan siya and then suddenly you will have your inflection point. Pangit lang yung curve ko. So, pwede ganun. You start from a high pH, especially if your analyte is at base. Then you suddenly have a slow change in the pH and then biglang mag-change yung slope. Okay, something like that. Okay? So, baka isipin nyo kasi ganito parate, no? You can do the reverse, no? So, that depends on the pH of your analyte. Okay? And titration process usually comes in 4 stages: the initial, pre-equivalence, equivalence, and the post-equivalence. Okay? In the initial, basically you have not added any titrant yet. Wala ka pang ina-add na titrant. Okay? So, even though wala kang in-add na titrant, there will be a certain pH value, of course. No? However, in the pre-equivalence point, ibig sabihin, bago siya matapos yung reaction, that means you added some amount of titrant already. Okay? Nagpatak-patak ka na ng titrant. Okay? So, that's pre-equivalence point. And then, upon adding certain amount of titrant that is stoichiometrically equivalent to your analyte, meaning the reaction is complete, you will have your equivalence point. And the equivalence point gives us the end point as well, meaning the color change happens here. Okay? And the equivalence point or end point is characterized by what's called an inflection curve. Okay, an inflection curve is a very steep slope. Okay, masyadong malaki yung slope niya. And then sa post-equivalence, you just added too much titrant na. So, kumbaga sobra na. Okay, sobra na yung nalagay mo. Okay, so kahit gaano karami na ilagay mo, kulay pink na talaga siya. Okay, so ganun. Okay, so you have 4 stages in titration. Initial, you have not added any titrant. Pre-equivalence, you added small amount of titrant. Equivalence, you just added enough amount of titrant. And then post-equivalence, you added too much titrant. Okay? So, yun yung mga keyword natin. No titrant, little amount of titrant, enough amount of titrant, and then too much titrant. Okay? So, when adding volumes, of course, you have to be very careful. Okay? So, yan. Let me show you the titration process, no, na ginagawa namin sa isang school. As much as possible, gusto ko sana siya gawin sa inyo din, but wala tayong chemicals. Masyado mahal, so wag na lang. Okay? Let me show you how we did it. Okay. Ayan. So, sa Blue School, sa Ateneo, ito yung experiment namin. So, we have titration. Itong kit kasi nila to mahal to eh. So, 2,500. Mayaman naman sila. So, sige. Okay. So, ganito, bale. We don't have burette, no? But what we have are dropping bottles. Okay. So, let me show you. Hinaan ko lang audio. So, yan. This is titration process na. So in the titration process, you measure certain amount of analyte. Okay, in my case, that's 2.5 ml of sugar. Sugar tuloy. Vinegar. Okay. So yan, nag-measure ako ng vinegar. And then I transferred it in an Erlenmeyer flask. Okay. So once I have the analyte there, I added some phenolphthalein so that it will change color upon adding titrant. Okay. So and then I just shake it, and then you now add your titrant. So wala kaming burette, so dropping bottle lang. So look at what will happen upon adding your your titrant, the color changes, na? So, di ba clear yon? But with the help of phenolphthalein, it turns pink. Yan. So, ito, pre-equivalence point pa lang. Kasi as you can see, yung pink color, it fades out. Okay? So, this is the pre-equivalence point. But later, I'll reach equivalence point. Okay? Ayan. Ito actually, post-equivalence na yan kasi super dark. So, yan. So, kapag super dark, that's not really advisable. Okay? So, you have to redo the experiment. Okay? So, add your phenolphthalein uli and then add some titrant. Okay? And so, ulit-ulit. Nakakangalay yan. Promise. Pero masaya. Okay? So, hopefully, kapag nag face-to-face na, ma-try nyo pa rin siya. Sayang lang, you lost significant amount of time, no? Para lang sa experiment. Ayan, so this is what we want, faint pink color. Okay, unlike the darker one that I shown you earlier. Okay? Ayan, so faint pink color lang yung gusto natin. Okay? Kasi kapag too dark, that tells you that you have so much titrant na. So, kumbaga, you are in the post-equivalence point. But kapag faint pink lang, you are at equivalence point. Yan. So, ayun, just as I mentioned, there's lots of titration. One of them is the neutralization reaction. That is the thing that I am discussing kanina pa. So that's neutralization titration or acid-base titration. Okay. So in an acid-base titration, we determine the concentration of acids or bases in your sample. Okay. And this one is easy to use. No? Madali siya gawin. No? Kasi minimal lang yung preparation niya. Okay. But if you are a BS Chem student, no, you will be more exposed to different types of titration. We also have this thing called the complex symmetric titration, wherein pag sinabing complex, kumbaga you have your metal being trapped by this is EDTA or ethylene diamine tetraacetic acid. Okay. So we have our metal being trapped by a chelating agent. No? Yung chelating agent, the Greek roots for it is the klo, okay? Yung chelate is klo in Greek, no? So, kumbaga, this is your metal ion and then this is your EDTA, let's say, a chelating agent. It will clamp onto your metal. Okay, so ika-clamp niya. And as that happens, may color change na mangyayari. Okay? So, mag-a-add ka rin ng indicator, of course. You have to add EMB. I just forgot. Sorry, EBT. Nakalimutan ko lang yung tawag doon. Because it's been a while since I last did this. Okay. So, we'll add EBT, indicator. And mapapansin nyo, the color is very different na. Kapag acid-base phenolphthalein, it's just pink na. Pero kapag complex symmetric, yan. So, mas colorful siya. So, it begins with this faint of this shade of purple, pink. Then suddenly, magiging blue siya. Okay? And then when we have a blue solution, that means the titration is done. Okay? So, other types of titration includes precipitation titration. Okay? And redox titration. So in precipitation titration, this is actually analogous to your gravimetric analysis then, okay? Kasi you form precipitates, okay? And depending on the amount of the precipitate being formed, okay, the amount of titrant you added, ayun, you can do some calculations. Kumbaga alternative to ng alternative siya sa gravimetric, okay? And then the redox titration, ito yung nakita nyo sa TikTok earlier. Pink yung kulay ng titrant. So that's potassium permanganate. Okay, and then you just add it to your analyte. Okay, so in redox titration, you have your redox reaction, okay, wherein there is an electron transfer involved during the process. Okay, basta mapapansin nyo lang that at the end of each titration, there will be color changes. Okay, if the substance isn't colored, then you need to add indicator. Okay, kailangan ba kabisado nyo yung color changes? Yes. Okay, so yan. So, kinakabisado namin yan as chemistry students, no? Pero kayo, acid-base titration lang naman yung focus ninyo. So, all you need to look for is the pink color. Okay? So, yan. So, those are the 4 types of titration with different ideas, no? So, for acid-base titration, you just react your acid with base until it neutralizes. For complexometric titration, you have your metal and you want to chelate them. Yeah, this is the spelling of chelate. Okay. Okay, when you say chelate, you clamp your metal into your complex. No? So, ito yung ginagawa when you are, let's say, you're working with Maynilad. Okay. Sa Maynilad, yung mga chemists done, they determine the calcium in the solution, okay, and the magnesium as well. Okay, so they do complexometric titration. And then for precipitation titration, pwede ito sa mga argentometry, okay, when determining the amount of silver. Ayan. And then for redox titration, basically may electron transfer during the reaction. Okay. So, yun yung mga types of titration. And again, kanina ko pa ito sinasabi. So, kapag endpoint, this is the point wherein the color change happens. And the equivalence point is when the reaction is complete using stoichiometry. Okay? Both of them overlaps each other naman. Okay? So, nag-overlap naman sila. Basta ang alam natin that the equivalence point is done using theoretical calculations using stoichiometry, but the endpoint is the one being obtained experimentally. Okay? So, alam niyo ba, hindi lang naman phenolphthalein yung indicator. Okay? Kasi yun yung pink na color, di ba? So, it's not always phenolphthalein. Okay? It actually depends on the equivalence pH of your solution. So you can use different types of indicators. Okay, other than phenolphthalein, we have the alizarin yellow, the bromothymol blue, the bromocresol green, and the methyl orange. No? So yan. So each of them will have different colors at different equivalence points. Okay. So hindi lang always pH 7, ha? So meron ding ibang pH na ginagawa kami. Okay. And to show you their color changes, so we have this color chart. Dati kinakabisado namin to, pero nakalimutan ko na. Okay. So yan. So for different types of titration, you have your different color changes per different pH. For example, in complexometry, ito yung EBT na sinasabi ko. Area chrome black tea pala siya. Nakalimutan ko na. Okay. So, ito yung ginagamit sa complexometric. Okay. So, you can see, ito yung bluish shade na endpoint. Okay. So, it starts pinkish. Okay. And then ends up dark blue. But if you have a light blue here, okay, just as I shown in the earlier slide, pag medyo light blue, okay, yun yung gusto natin. Okay, so this is also why titration is very fun kasi iba-iba yung colors niya talaga. Okay, so alam niyo naman kapag chemistry student, hindi lang nerd, no? Kumbaga may pang IGD ka rin dapat. So, I remember during our time, we have so many indicators kasi. So, ginawa namin. Pinaghalo-halo namin sila. And then, just created a collage, no? Uso pa nun yung collage. Okay? So, yan. So, very colorful ta. Okay? Let's look at the phenolphthalein. As you can see, the phenolphthalein color change doesn't happen at pH 7. It actually happens around pH 9. Okay? However, if you look at the inflection point kanina, masyado siya mahaba. So, pH 7 is kumbaga, it is equivalent to pH 9. Okay? So, that's why yung color nagbabago. Okay? So, yan. So, may range siya, and that range is usually within the titration curve naman. Okay? So, yan. And ito nga yung sinasabi ko sa inyo, sometimes we have different indicators depending on the titration curve. Okay, for example, if that is just monoprotic titrations, we can use phenolphthalein or bromocresol green. Okay, but commonly we use phenolphthalein. Okay, that's monoprotic titrations. However, if we have diprotic titrations, we need to use two indicators. Okay? So, hindi lang phenolphthalein yung ginagamit namin. We also need to add other indicators such as the bromocresol green. Okay? So, yeah. So, depending on sino yung magbabago yung kulay, we can infer what substances are in the sample. Anyway, you will learn more about this in the final period, no? So this is chapter 5 in the laboratory kasi. Okay? So basta yun lang tandaan nyo, no? So hindi lang naman limited sa phenolphthalein, we can use different indicators, na? So each of them have different pH colors, na? Okay? And then sometimes you can use multiple indicators, na? Minsan pinaghahalo namin yung dalawang yan. Okay? So, yan. So, let's look at into the titration process. No? So, I think ito na yung last part ng discussion natin today. We'll just have the terms. No? So, in doing titration process, usually 3 steps yan. Of course, you prepare your titrant solution, you standardize it, and then after standardizing, you titrate it with your analyte. Okay? So, in preparation of your titrant solution, as is yan. Okay? So, kumbaga, you will weigh certain amount of certain amount of titrant, and then you dilute it in a volumetric flask. So, ganun yung preparation of titrant. Okay? So, what are the titrants used ba in analytical chem? Okay? So, if this is a neutralization reaction, so these are the titrants we always use. Okay? If you want to use an acid titrant or an acid standard, ang ginagamit parati ay hydrochloric acid. Hindi ibang acid, kundi hydrochloric acid talaga. Siya yung standard. Siya yung typical. Okay? And hydrochloric acids are standardized. Pag sinabi kasi natin standardized, you just determine the exact concentration. Okay? Diba, pwede mo naman makuha yung concentration using the mass, right? Okay. Pero you want to make sure that it is the exact concentration. So that's why you standardize it. Okay. So don't worry, I'll explain it further with calculations in the asynchronous video. Okay. So kumbaga, just remember na lang that when you prepare your solution, you have your known molarity. But we should not be satisfied with it. We always standardize it. The purpose of the standardization is to just make sure that it is the exact concentration. Okay? And in standardizing your titrants, we usually present our values up to 4 decimal places. No? So, meaning sure kami na yun talaga yung concentration niya. Okay? So, yan. Hydrochloric acid is the common acid titrant, and we standardize it against sodium bicarbonate or sodium carbonate. Okay? So, yun. So, when we add hydrochloric acid with the sodium carbonate or sodium bicarbonate, na nangyayari, the products become neutral. Okay? And that will be indicated by a pink color by the phenolphthalein. So another standardizing agent we use is the 3-hydroxymethylamino-methane. Pero I actually don't have any experience about this. Wala akong experience dyan. Itong sodium bicarbonate lang talaga or sodium carbonate meron. But if your laboratory is good naman, okay, may enough money siya, so pwede siya gumamit ng trees. Okay. So this is the trees and it is also used in standardizing acid. Although mahal to. Itong sodium bicarbonate kasi, sodium carbonate, mura lang siya. Kaya ito yung ginagamit namin parate. Kapag base naman, so hindi lahat ng base ginagamit. Okay? So just like acid, no? Kapag acid, you use HCl, but when you have a base, what we usually do is what we usually use is yung sodium hydroxide. Okay? Potassium hydroxide can also replace and barium hydroxide. But the common one is sodium hydroxide. Number one, because it is inexpensive, mura lang siya. And number two, it is standard na siya. No? So standard na talaga siya in the laboratory. However, unlike acids, no, in preparing base solution, you have to boil it. Okay? So, yung acid kasi, you can just simply add water, no, as is. So, you don't need to boil anything. Okay? Pero dito sa standard base solutions, you need to boil the water pa before adding your titrant. Okay? So, kailangan mo pa siya pakuluan. Why? Because the sodium hydroxide can actually react with the carbonic acid or the carbon dioxide in your solution, in your water. So, kailangan, in order for you to eliminate the carbon dioxide, you have to boil it. If you recall your Gen Chem, that's Henry's law. Okay? Okay. So, kailangan pakuluan mo siya para mawala yung CO2. Okay? Kasi kapag hindi mo ginawa yun, the sodium hydroxide can react with your carbon dioxide and it will cause changes in the concentration. Okay, and since that happens, we have to standardize the bases. The typical standardization solution that we use against bases are potassium hydrogen phthalate or KHP. You will know a person if that is a chemist kapag kaya niya i-pronounce yung phthalate. Kasi yung iba nag-struggle dyan. Phthalate daw. This is just pronounced phthalate. And this one is pronounced phenolphthalein. Diyan mo malalaman kung chemistry student yung isang tao. Ipapronounce mo yan. Phenolphthalein and phthalate. Okay. So remember, ang standardization for acid, it's either sodium carbonate, sodium bicarbonate, or tris. Kapag bases naman, ang typical na ginagamit namin is the potassium hydrogen phthalate. Okay? And then sometimes we also use benzoic acid if available, or potassium hydrogen iodate. Okay? But ako, based on my experience, I actually use KHP always. No? KHP parating ginagamit ko. Okay? So, ito yung reason why we have to boil the water because of the carbonate error. No? So, what happens kasi when you have your carbonates, no, or you have carbon dioxide in your water, is that it turns into carbonic acid. No? And that carbonic acid can react with the base, which causes it to have lower molarity. Bumababa yung molarity niya kapag may carbon dioxide. So, whenever you have your base titrant, kailangan hindi siya exposed sa air. No? So, medyo hassle siya, pero ganun talaga. Okay? So, kailangan pakuluan mo pa talaga, no, before you add your, sodium hydroxide. Because, again, what will happen is that, if may carbon dioxide in your water, what will happen is, magre-react yung sodium hydroxide sa carbon dioxide, no? Okay? And carbonate error is nagpaproduce siya ng carbonic acid, no, which reacts with sodium hydroxide, causing it to have lower molarity. Calculation na pala. We have plenty of time pa. Pero okay. So, pero ano na lang. So, next meeting na lang itong calculation, ha? Okay. So, I'll create a separate video on this para mas madali hanap nyo sa videos natin. But basically, that's the titration process. Okay? So, tapos na pala tayo. So, again, just to summarize everything. So, titration is just your volumetric analysis. You add certain amount of liquid to another liquid. Okay? You add certain amount of titrant to your analyte, and depending on how much of the titrant was used, you can do your stoichiometric calculations to identify the concentration of your analyte. And the typical titration that you see in TikTok is actually neutralization reaction. Okay? Just remember, kapag neutralization reaction, you just add your acids and base until they become neutralized. Okay. So, yan, in titration, you just add few amounts of your titrant, onti-onti lang, until a color change appears. The color change will happen upon the addition of an indicator. Okay? So, this is the video we watched earlier. And, sabi ko, in titration process, there are 4 steps, no? Initial, you have not added any titrant. Pre-equivalence, you added just few amount of titrant. Equivalence, you have added enough amount of titrant to completely react with your analyte. And in the post-equivalence, you added too much titrant. Okay, sobra ka na. So, ayaw mo na yan. Okay, so as you can see, the titration curve is characterized with an inflection curve. Ayan, may inflection curve siya. Malaki yung slope change dyan. So that's why we have to do the titration dropwise, because just a few amount of your titrant can literally shoot up the pH of your substance, of your solution. Bigla siya mag-shoot up. No? You have to be very careful. And there are many types of titration. We have the acid-base, the complexometric, the precipitation, and the redox. Na? Okay. Pag acid-base, you just have your acid, your base, you react them to form neutral compounds. If you have complexometric, you have your metal, you chelate it. When you say chelate, ibig sabihin umiipit na nagka-clamp yung iyong chelating agent sa metal. Okay? And that is also characterized by a certain color change. In the precipitation reaction, usually we use silver dito, argentometric, may silver dyan. So yun, you add just certain amounts of silver so that you can determine how much analyte are in there. So sa Maynilad, ito yung ginagamit din to determine the chloride ions in the water. Di ba nilalagyan ng chlorine yung tubig? Literal na chlorine yun para mamatay yung bacteria. However, minsan kapag nasobrahan ng chlorine, hindi lang bacteria na mamatay, pwede rin tayo. Okay? So that's why yung mga nasa Maynilad, they use precipitation titration to determine how much chlorine was added to the water before supplying it downstream. So inaalam nila yan sa Maynilad. And then for redox titration, you have your electron transfer reactions. Okay? May mga oxidation reduction reactions. Okay? So yan, just as I said, yung endpoint ito yung kung saan nangyayaring color change, equivalence point. This is calculated using stoichiometry. And we are not just limited to phenolphthalein, rather we can also use different indicators. Na? And those indicators have different color changes. Okay? So, ayan. And then sometimes we need multiple indicators. So, hindi lang isa pwede gamitin, pwede rin combination, na? Such as in determining sodium carbonate and sodium bicarbonate. Okay? We'll explain this further in chapter 5 sa laboratory. So, after midterms na yan. Okay, and in the titration process, you prepare your titrant solution. So basically, you just get your volumetric flask, you dilute your sample, okay, and then dilute it up to mark. So you have your titrant solution. Even though you have your concentration na, you have to standardize it. Na. When we say standardize, we really need to get the exact concentration. So I'll show that in the calculations na, in the video na lang. So the titrants that we use in neutralization titration, pag-acid, that's hydrochloric acid, we standardize it against sodium carbonate or sodium bicarbonate. Kapag yan naman ay, pwede rin naman yung trace, but I never use this. Mahal kasi siya. Kapag base naman ang ginagamit, we usually use sodium hydroxide, but when dealing with sodium hydroxide, you need to boil the water. Okay? And we titrate it against this molecule here called potassium hydrogen phthalate, okay, or KHP. So yun. Okay, and the carbonate error tells us that when you have carbon dioxide in the solution, it actually becomes acidic, and that acid can react with your titrant, causing its molarity to decrease. No? So you will have inaccurate results. So that's why you have to boil the water talaga. Okay, so you really need to boil it first. So itong titration calculation, I'll create a video about this na lang. Basic lang siya compared sa mga pinagkagawa natin earlier this month. As in, super dali lang niya. Kasi you will just need to use molarity equation and then dilution equations. Okay? So, sa video na lang to ha. Okay. So, for now, chill muna tayo. Okay. So, yan. Create a video about these problems here. Okay? Ayan. So, that's our lecture agenda for today. Do you have any question? Kasi yun na yan. Okay? Medyo chill na yung chapter 4 kasi pa-midterm na eh. So, chill muna. Okay? Sa laboratory lang yung walang chill. No chill. Okay. Anyway, so that's the end of our discussion for today. I hope you learned something, especially about the titration process. Even though we are, kumbaga parang sayang yung time, no, that we are doing online classes because you have not developed the skills, no, in the laboratory. But I hope that you have an idea na, okay, so that when you do the actual experiment, so, when we go face to face, I think sa August face to face na, ayun. So sana kaya nyo gawin. By the way, just to remind everyone, tomorrow is March 1, which is Alert Level 1 for Metro Manila. There will be less strict, mas mababa na yung restrictions niya. Okay. So, Alert Level 1. This is for everyone na rin. So, sabihin ko na rin. So, ano ba meron sa Alert Level 1 starting tomorrow? Ano lang siya, parang wala ng COVID. Meron pa bang COVID? Diba? Makikita mo yung mga tao, dami-dami. Na nag-Star City kami last time. Nag-Star City ako last time. Grabe, ang daming tao. As in, 40 minutes bago kami makapasok sa isang ride. Okay lang. Nahilo din naman ako. So, sige, okay na rin. So for alert level 1, we will expect more people going out, but still be careful. Huh? You have to take care of yourself. And if you have a chance to get your booster shot, please do so. I think some of my students are actually telling me na nag-booster sila last time na. So that's why hindi sila nakapag-take ng quiz. And that's fine with me. Okay? So yan, we will have much looser restrictions na. Okay? So pag transport, nako, kahit full seating capacity na. And di ba, ganun naman talaga. Sa jeep nga, siksikan. Mas malupit sa bus, may mga nakatayo na rin. Parang walang COVID. Oh, when it comes to contract tracing, wala namang ganyan eh. Okay. Testing for unvaccinated na lang. Okay. Pero hindi na siya parang hindi na siya masyadong required. Okay. Ayan. Anyway, so things are getting better naman due to vaccine. So we have to be thankful na rin, okay, that vaccines are there. Okay. Okay. So even though medyo skeptic tayo, pero may vaccines na rin kasi. Okay? But still, we should not be too confident na makakalimutan na natin yung basic safety protocols. Okay? So yun. So with looser restriction, I hope that we'll see each other sa susunod ng mga face-to-face sana. Ano? Okay, hopefully by August na makita-kita tayo sa school. Okay, so I'm optimistic although kind of skeptic pa rin. Okay, ayan, basta ingat lang. Especially for those attending political rallies. Kaya mga pumupunta ng Star City like me. So, yeah. So, ingat lang. Okay? I'll post the asynchronous video this Wednesday. Okay, so sa Wednesday ko siya gagawin. So, I'll post the video on the calculations. Madali lang to, promise. Mas madali kaysa sa ginagawa natin sa equilibrium. Kasi, remember, equilibrium may mga quadratic. And this portion of the calculation, wala. Super basic lang siya. Okay? So, yan lang. So, I guess we are done with the discussion. So, thank you for attending the session. And again, if you have any questions that I have not addressed yet, just let me know na lang sa chat box. Okay? For now, just rest muna and I will see you again in the laboratory class later. Okay? Para sa mga hindi ko students sa lab, so I'll see you next time na lang. Okay? But before I end this video, I'd like to remind everyone that midterm is fast approaching. Okay? I already posted all the deadlines in the quizzes problem set. Actually, open na yung problem set. You can submit it as in advance. Okay? So, yun. Yan. Pero even though maraming deadlines, you can talk to me naman kapag kunwari overwhelmed na kayo. You can tell it to me na okay, naunawaan ko naman yung situation ng mga students na. Kasi ako rin. The reason why medyo late yung aking responses earlier kasi last week I had my finals. So, naunawaan ko na medyo ano rin kaya nagagahol. So, in case na you have problems, especially you feel that you're not in good shape to take the quiz na, so let me know lang. Or if you have difficulty, o kaya kunwari may sakit, no, may na-COVID, meron akong students na na-COVID din kasi lately, just let me know so I can make necessary adjustments. Okay? Basta ang tandaan, mag-ingat lang parate. Okay? So, I'll see you again in the lab class later. So, yan. So, bye-bye muna for now. Okay? Ingat. And I hope you learned something. Bye-bye.